Hello and welcome to Standard Deviation and Skew. I'm Mrs. Burton and we will be talking about this topic today. Please remember you can pause to take notes at any time or replay the video as needed to get all the information you're looking for. What we already know that we're going to use today, the first thing is how to find the average or the mean. We've already talked about the three central tendencies, and one of those is the mean. So if you remember, you calculate that by adding up all of your data points and dividing by the number of those points. So what is exactly the standard deviation? The definition is a measure of how spread out the numbers are in your data set. You find it by finding the square root of the variance. We're going to talk about what the variance is. And its symbol is the Greek letter sigma. It's a small circle with a tail. So that is how you would denote the standard deviation. The variance definition is the average of the squared differences of your data from the mean. So in order to calculate it, you first have to work out the mean or the average of the numbers. Once you have that, for each of your data points, you're going to subtract the mean from, the mean from the data point, and then square the result. That's called the squared difference. So you're going to work out the mean or the average of the squared differences. So what does all this mean? If you take some data, so here we have a set of data where they've calculated or measured the height at the shoulders of these different dogs, different breeds of dog. So we have a height of 600 millimeters, we have 470, we have 170, 430, and 300. So if we wanted to talk about the relationship in the heights of these dogs, we might want to find the standard deviation. So we're going to start with the data of the heights at the shoulders, and those are listed there. Once you have that, you're going to add them all up, and since there's 5 data points, you're going to divide that by 5, and that's going to give you the mean of the values. So the mean is the average of all of their heights, and so that's what this line is right here. If you wanted to see what dog was at average height, that would be the mean. Looks like this terrier here is pretty close, is closest to the average height. The next step in finding the standard deviation is taking these data points and then subtracting the mean. And the mean is known as the x bar. So that's this x bar here. So you're going to take 600 minus that mean that we just calculated, and you're going to get 206. And then you just square that number. So each one of these, you're going to subtract the mean and then square the number. You'll notice in the third one, that number is negative. But once you square it, it's a positive number, which is kind of the purpose for squaring these values. So you're not looking at a relationship based on negative numbers. You're strictly looking at the relationship of the difference between the mean and the actual data point. So it doesn't matter if it's positive or negative. That's why you go ahead and square it and you take the negative totally out of the picture. So then we have to divide it by a number. So we found the variance, and there are 2 things you have to look at when you're deciding what number to divide it by. The first one is if you're working with the population, you're collecting data from all the members of the population, you're going to just divide by that number. Well, obviously there are more than 5 dogs in the population, so we're talking about just a sample of those dogs. So in order to work with samples, they make this correction and they subtract 1 from your data set. So in this case, we would have 5 dogs, but we're going to divide our number by 5 minus 1, or 4. In most of the cases for the data you'll be working with, you're going to want to use this n minus 1 for your calculations. Very seldom will we use just the n. So typically in your formula, you're going to see n minus 1 as the number that you divide the variance by. So if we finish it, we've taken our total, divided it by 4, that's our n minus 1, and that's our variance. And then once you take the variance, once you have the variance, the standard deviation is the square root of that variance. So you take the square root, and our standard deviation for this data set is 164. So what does that mean to our data set? If we look at the picture again, here are all of the dogs' heights, and then you have the mean, that's their average. And then one standard deviation is 164 on either side of that mean. So the dogs that their heights at their shoulders are within one standard deviation are these three. You've got the Boston Terrier, the Terrier, and looks like a Greyhound. Now the Rottweiler, he's not within the one standard deviation. He is on the outskirts of that first standard deviation on the tall side, and then this little Dachshund, he's on the outskirts of the first standard deviation but on the small side. So the standard deviation is really telling you where the majority of your data lies. So 3 out of the 5 are within one standard deviation, and then 1 higher and 1 lower are outside of that standard deviation. So here's what the formula looks like. This is something you won't necessarily need to memorize, but you do need to know how to find it. So you're taking what we did, we took the sum of all of our data points minus the average and squared it, and then we divided that number by n minus 1, and then we took the square root. Okay, so in this case you'll see S for standard deviation. Remember, we also said sigma was a number you could see for standard deviation, or a variable that you might see. So the other thing we're going to talk about today is the skewness of data. Both of these things kind of show you how your data is laying out so that you can look for trends and make projections. And you're going to look at 3 possibilities for skewness. You've got the negative skew, no skew, or positive skew. And this is how that data looks in general for a negative skew, and then the no skew, or a normal distribution, this is also called, and then a positive skew. So you can tell some of them by looking at the picture, but if you're not sure about the picture, there are other ways to figure it out. First of all, with the negative skew, you have what's called a long tail on the left side. So you have a longer variation in the data on the left side. So how do you know when that is? Well, the mean, in this case is located here, is located to the left of the peak, and the peak would be your highest data point. And you have your tail on the left, the long tail is on the left, and this is known as a negative or left skew. Then you have the normal distribution, or no skew. In this case, your median, your mode, and your mean are all at the peak. They're at the same place. So your mean is exactly at the peak, and your data is all symmetrical. So you have the same number of data, the same data points on the left as you do on the right. So it's known as a normal distribution. You might have heard of it as kind of a normal bell curve also, or no skew. So there's no skew. It doesn't kind of tend either direction. And then the last one is your positive skew. And again, you have your long tail over here. This is the mean of the data. So if the mean of the data is to the right of the peak, that's going to indicate a positive or a right skew. Also, the tail is again to the right, which gives you a right or a positive skew. And then that's how that's known, positive or right skew. So your mean is to the right of your peak, and that gives you the right skew. So you've gone over standard deviation, variances, how to find a standard deviation. We've talked about what the standard deviation represents, and We also want you to think about why do you think the difference between the data point and the mean is squared before finding the mean of the variance. So these are the questions you'll want to come prepared to share with us at class tomorrow, as well as the filling out the notes on the guided note sheet. If you have questions, please bring those with you. And in the meantime, you can stop and restart this video or put it to the places where you want to take some notes. And we will see you tomorrow in class.